Scott Schramm is the former Iowa DOT pavement management engineer, now working as an Iowa DOT district engineer. His prior role as the state's bituminous engineer. Scott holds a Bachelor of Science in Civil Engineering from the University of Nebraska, go Cornhuskers, and PhD in Civil Engineering from North Dakota State University. I will turn it over to you.
Good morning, everyone. I could go on and on about what we're doing in Iowa as far as asset management goes. They kind of told us to keep it to about 10 minutes so we could have some panel discussions here. So each of the panel members decided to tackle one of the issues, and my charge was to talk about the data collection aspect. Disclaimer, this is based on the proposed rule. We'll get the final rule next week, or maybe by MAP 22 comes out. IRI cracking, rutting and faulting, that's how we're proceeding, assuming nothing changes. Everyone knows we're on a 0.1 mile aggregation. That's probably different than some of you are collecting. Interstate is annual, and the non-interstate biannual. That's kind of the basics. That's how we plan our work. I can tell you, when you're getting down to a 10th mile, you're really, the only way to achieve that is through automated or semi-automated collection. I can share with you the cost of our operation. That's the biggest question folks want to know. We've used a vendor since 1998. We've had various vendors, but we've been doing semi-automated since 1998. And these costs are shown here for both the right-of-way imagery as well as the downward imagery for the pavements. Like I said, we've been doing this a long time, and actually the costs are getting more, it's coming down. To address some of the local non-HS, we collect everything. We pay the bill for whether we have jurisdiction or not. That decision was made back in 2012. Prior to then, we only collected our system. That amounted to about 12,000 paved miles. Now we collect all paved miles. So that's about 41,000 miles every year. So we're on a 2-year, we collect half the system each year. So this adds up to about $3.5 million a year that we spend on data collection. The bulk of that is the local cities and counties. And we are one of the states that had a 10-cent gas tax increase last year, and we couldn't do that without first telling the story of the entire system. And in order to do that, we prepared back in 2012 we committed to collect all the information on all paved roads, all public paved roads. So it is a challenge. But if you've been doing it since 1998, maybe not. It's not any different than what you've been doing. Some of the challenges that come with that, if you really get into the millions and millions of rows of data that will come into you from your vendor or from your internal forces, that's another important note, is these are for vendor costs. If you have an in-house operation, they're going to be different. Missing data will be counted as poor. That was the proposed rule. I don't know what deviations the official rule will be from that, but I know that lane deviations, construction maintenance activities, bridges, those are, you're going to have to keep an eye on those. Those start to add up. You get a gas tax increase. We're increasing our program by 30%. It means we're doing more work out there. It means we got more work zones, more closures, more potential for those zeros to come up. So you really need to be on top of where you have those activities. And the best solution for that is your quality control. And I know that's also part of the rule. You have to have a quality control plan. So we use a lot of statistics. We compare standard deviations and means and populations. We're doing historic trend analysis. We're cross-checking with construction activities. It could be as simple as we've got an analytics team, and if they see 100 rows in a row that are all zeros, and they know there wasn't any construction work in there, then they go look at the imagery to see what happened. And sometimes they just, we tell the vendor and it was just a reporting mistake. So, but you have to do that now because there's consequences. Here's just an example of what we do for trend analysis. So you can follow rutting along a certain pavement section, and then after you aggregate the data, that the newest data point better follow the trend. If it doesn't, we've got a problem. Or if at least we can't explain why, then we've got a problem. And finally, and what's it all for? Well, it's to help us manage. I mean, there's two sides of the sword. You've got on one hand, we've got rules that were never in place before, but they're there to help. So you can look at the bright side. Ed had some graphs that showed declining condition over time at various funding levels. I could show you 100 graphs, but this one kind of speaks to Iowa as far as preservation goes. If you hold like your year 10 on that analysis and you plot budget on your x-axis and condition on your y, and you can see how that condition changes as you throw money at your preservation activities, you can see you're really gaining ground. But at some point, you all have your own condition index that you've developed. You know what it takes to move that needle by 1 point. It might only be 1 point, but that could be $20 million to move that needle. So preservation can help move that needle, and that's what we've found. And it's a tool to show your commission, highway commission, show your stakeholders that we need to be investing. And the other advantage of the data collection is modeling. We use an optimization tool for our pavement management system. I know it's common for states to model their condition over time, as in maybe it's a PCI or PCR. So you model that one number over time, but what we do is we take each individual distress and we model the distress. That way in our decision trees, we align the symptom with a solution. So the treatment goes with the symptom. And PCI isn't a symptom. Cracking, rutting, faulting, IRI, those are symptoms. The type of cracking is a symptom. So we've been able to use our data since 1998. We've got great trends. So we've got a model for every section of road. We don't do families if we can avoid it. If pavement's been out there 8 years, we should have enough data on that pavement to know where it's going all by itself, and we can tackle it that way. That leads us to better modeling capabilities. If you look at our microsurfacing activities, you can see on the x-axis we've got time. So we've got negative time. That means the data points to the left are towards the end of that, just before the treatment was applied, backing up in time. And we found that if you do a microsurfacing when there's greater than 10% cracking, what you get then is, if you follow the 10% cracking across, you get about 3 to 5 years of benefit. But on the other hand, if you get ahead of it, and it's more of a preventive nature, and you apply the microsurfacing prior to that 10% threshold, you get much longer life. And it's data that tells us this story. And so then we take this information and we plug it into our optimization tools, and then it helps us pick when and where, right treatment, right time. So there's much to be gained by having that 10th mile aggregation data sources. So that's all I had. Again, we'll answer questions as a panel when we're through with the presentations. Thanks for your attention.